Um, so, don't forget, as usual, don't forget to do your seating survey. Chem 112, Section 2, rooms ILC 118. And upcoming due dates, I pushed the homework 5 slightly once again to this Friday. The reason for that, rather than the Wednesday that I had originally said I was pushing it to, is because I'm doing these exam debriefs Monday and Tuesday, and so Wednesday and Thursday will be the days when I can really address the content questions that are coming up about this material. And so I want you to have a chance to take that information and use it as you finish that homework. Everything else is being pushed until at least next week. The homeworks are getting reshuffled, and I don't know exactly how that's working just yet. So right now, what it looks like in Blackboard and Newton is as though this week's homework is just all due in addition to next week's homework next Friday. That is not going to stay that way. That is just a holding position for me to put it to while I figure out how to better redistribute things for the rest of the semester. So this leaves us with less specific assignments for this week. And so the things that I am asking you to do primarily involve 3 videos that are going on here. First one is an exam walkthrough, which is a full explanation of each problem on the exam, performed on screen, worked through. It's long, it's about an hour because, as you know, it was a relatively long exam. There are some very good reasons to spend that time doing it, specifically with respect to regrade requests, which I'll talk about in just a second. There is also a video on frequently raised objections on Piazza, which addresses 5 major objections that have been raised in that discussions there. They go into quite some detail on my thoughts and responses to these objections. And then also at the end of it, what exactly we're doing as we move forward, both in terms of what I'm going to be doing and what I'm asking of you to do as well. I'm going to very briefly go through the 5 objections here, but I want you to know that what I'm saying here in class is a short version rather of this, and not going into all of the details. I'm just calling out a couple of highlights in each of the various areas. So one thing that was very frequently mentioned was this exam was not like Newton. And my basic response to that is that's right, it wasn't like Newton. And I told you before the exam that it was not going to be like Newton. Newton does one thing really well. What Newton does very well is it gives you repeated problems of exactly the same type and drills you on them and gives you good explanations of them so that you can learn to do exactly those types of problems again. That is an important sort of baseline skill, but that skill is not the same as meaning that you understand the material. And so the idea is that what we are trying to do is move past just being able to regurgitate information or be able to repeat a problem that you have seen before. We're trying to get to the stage of understanding the concepts at a point, to a level where you can make connections between ideas and and then apply the ideas to a situation that is slightly different from what you have seen before. A very good example of why this is critically important. In this class so far, we, in the very first week, we were talking about intermolecular forces, and we were trying to go down some examples of here's a compound. We have a list of intermolecular forces, and in order to determine if it's if it has certain intermolecular forces, we need to know, is this an ion or not? Are there ions in this? And when I ask that question, I get blank stares. And then I get people saying, how do you tell if it's an ion? And this is the kind of thing that was covered in quite some detail in Chem 111. In many other examples throughout the semester so far, there have been cases where we are working a problem and we get to a point and, getting from here to the final solution is just dimensional analysis. It's converting units. And again, I get blank stares and I get people saying, well, okay, can you take us through exactly how to do that by plugging in the specific numbers to show how to do that? Dimensional analysis is one of those skills that is just so absolutely critical to solving any chemistry problem that I would hope that at this stage in chemistry, more than a semester into it, that would be second nature, that you can say, okay, there's something in grams, I need it in kilograms, I do the conversion. I have something in moles, I need it in grams, I use the molar mass. And these things should be absolutely second nature going through it. And yet, what I'm finding in trying to work through problems with students is that those are not second nature, those are not automatic things that are coming forward. And so I'm not saying this to make you feel bad about what you're doing or what you know coming in. What I'm doing is saying that I will pretty much guarantee that in Chem 111, you reached 100% mastery in those two concepts that I use as examples right there, and that you took a Newton-style exam on those concepts. And then now this year, you're unable to apply those concepts in context here. That is the best argument I can imagine to illustrate why a Newton-style exam is insufficient to demonstrate, do you understand it to the point that you are A, going to retain it, and B, are going to be able to apply it when it's needed to be applied later. So yes, I agree, the exam was not like Newton for very good reasons. Okay. There's also the issue of, well, if what we practiced on before the exam was Newton, then I haven't been prepared for doing doing what you're asking me to do. I understand that concern. Here's the thing. There are at least 3 areas of this class where I have specifically been trying to teach you exactly these skills. First example of that is the content videos. In the content videos, there are the quiz questions. And the quiz questions are specifically designed for you to be given information, you get to the quiz question, and you have the information you need to answer that quiz question based upon what you learned previously and the context in the quiz. And then what I was hearing on Piazza in several different places is, boy, isn't it weird that Osman's telling us after the quiz question what the answer is to the quiz question? Shouldn't he tell us what the answer is first and then test us if we know it? No, because the point is to go through the thought process of arriving at that answer. And if you arrive at the wrong answer at that point, I then give you I explain the answer so that you can see where your thought process was wrong. These questions are specifically designed to guide you through developing an understanding and learning how to take the ideas and combine them. The problem is that what I have found many students doing, based on looking on Blackboard and seeing how many attempts do people have at these quizzes, what people are doing is going through the videos multiple times, saying, well, these answers didn't work. Okay, well, these answers didn't work. Okay, and finally getting all of the right answers after going through it, and then going through and giving those answers. Treating the material as I need to remember facts and I need to be able to follow set procedures, rather than I need to be training myself to approach these questions and think about them and try to put the ideas together. And so that approach to the quiz questions in the videos is circumventing the entire educational purpose of those quiz questions, which is to prepare you to think about a new situation like I am giving you on the exams. Okay. Second, what I think is the most important component of this class, the small group activities. These small group activities are leading you question by question in a Socratic method based on Socrates, the Greek philosopher, who he would bring the people he was talking to an understanding they didn't realize they could have by doing nothing except asking questions, because he was asking the right questions to guide the person through a thought process. The small group activities are an argument. They are starting from initial concepts, building up those concepts so that you can then answer a later, more involved question, and continuing through until you get to the end. And finally, at that point, you have for yourself constructed an understanding under the guidance of the questions, and that is going to stick with you much longer and much more effectively than will be given the answer at the end. So, the problem that I've discovered with those is that many groups have approached doing these small group activities by dividing up the questions and saying, you do questions 1 through 10, you do questions 11 through 20, and so on, which again circumvents the entire educational purpose of these activities. The third thing, the third way that I am trying to prepare you for thinking the way you need to on these kinds of exam questions is working problems and going through explanations here in class. You may notice that when I'm doing these questions, working through an example or working through a concept, I will then ask the class a question and sit here and wait, sometimes for a painfully long time, for somebody to propose an answer. I'm not doing that to be mean. I am doing that because the thought process behind trying to answer that question and then throwing out an answer and seeing if it works, even if it doesn't work, that thought process is part of the educational process that you need to be going through. I'm asking those questions specifically to train you not what to think, but how to think, so that you can then apply those skills along with the content facts in combination to be able to solve problems. Why is that important? Why is that important? You are in this class for a reason. Even if you are in not a chemistry major, which most of you are not, I understand that, I grasp it. But whatever department you're part of, they've required Chem 112. They've required Chem 112 because the concepts in Chem 112 are going to be important at some point in understanding their content. How are you going to be able to apply this content to that context if you do, if the only way you can do this content is in the form of a Newton-style question? You won't be able to. So, this is why my exams are not like Newton. And I feel as though the primary ways that I have been specifically trying to prepare you for the ways in which they are not like Newton, a large fraction of the class has been short-circuiting, has been circumventing, because they're doing the quizzes in the wrong mindset and they're doing the activities in the wrong mindset. And in class, instead of trying to come to the answer that I'm asking for the question, people are waiting for me to get tired of waiting, and so that I will give them the answer. It's not about facts. Okay, so that's the nutshell version of this exam was not like Newton. The other response is I failed the exam. No, you didn't. So I'm going to explain the revised grading scale in a few minutes. But there is a very good reason why I don't assign letter grades to any component of this class. There are 300 points out of the 1,000 points in this class that are essentially almost guaranteed 100%. The Newton homeworks. I'm not assigning the supplementary questions anymore. If you just put in the work, you get 100 points out of that for the end of the semester. Participation on Piazza, you just post something or respond to a question, contribute a follow-up, you can get a full 100 points on that just by putting in the work. Content videos, much as I would prefer that people not approach it from the perspective of taking it multiple times and trying to get 100% on it, pretty much everybody is. There are very, very few students in this class that do not have 100% across the board on the content videos. So should I be assigning letter grades to those? That doesn't make any sense at all because everybody's getting 100%. So the other components of the class, like the small group activities and the exams, if I assigned a letter grade to that, what would that mean? Because everything's getting bumped up by these automatic, almost 100%, as long as you put in the work. In a few minutes, I'm going to give you a new paradigm for thinking about the grades, which I think will help you grasp that. We will get to that in a minute. You aren't teaching us. That's something I've heard quite a bit. So it is a mistake to think that teaching is lecturing. The reason that is a mistake is that there have been hundreds upon hundreds of studies on the effectiveness of teaching. And those studies have shown extremely consistently two things. The first, students think that lecturing is the most effective way for them to learn. But every time lecturing is compared to something else in terms of actual learning outcomes, lecturing comes in last. That is because lecturing has a mindset of the sage on the stage has knowledge and skills. You need to be passive receptacles of that knowledge and skills. And it is my job to fill you up with those knowledge and skills. But what is always shown to be better than that in terms of learning is for students to be active participants in the process, actively engaging with the ideas, trying something out and seeing if it works, being happy when it does, when it doesn't, being even happier because then they can fix something in their own thoughts and get better at it. Making a mistake is exactly what you need to do to learn. And when I used this phrase a minute ago in respect to the small group activities. When you construct your own understanding of it under my guidance, when you construct that understanding of it, you will retain it and you will be able to apply it because you know exactly where it came from. So I said that the lecturer model has the sage on the stage. The active learning model has the instructor as the guide on the side. And the idea is that what I need to do is to provide an environment in which you're able to maximize your learning. I pose difficult questions, but within the context of giving you the information you need to be able to figure it out. And where the information is not clear, we have to have dialogue and feedback in order for me to identify in what way it's not clear so that I can redirect you and guide you through it. That is why this needs to be a dialogue rather than a monologue from me to you. There's still a lot that I have to do in order to be an effective instructor in this guide on the side model. I'm constructing the sequence of questions, the sequence of thoughts that you need to go through in the content videos with a very careful attention to, I'm asking this question to elicit this specific connection in your mind. Same thing in the small group guided activities. Same thing when I'm doing it on the fly up here, trying to answer questions and trying to work through example problems. Instead of me saying, here's step 1, here's step 2, all the way through step 10, here's step 1, here's step 2, okay, what are we trying to get to next? What do you think the next step would be? How would you, what information would you need in order to be able to get that information? That's the process. That's how we get to understanding rather than remembering. Because remembering will go away as soon as you stop practicing it. Okay. This class takes way too much effort. I'm sympathetic to that, but I've gone through a couple of times, and in the video I'm asking you to watch, I go through it again, the sort of breakdown that you should think about for these things. So the general university level expectation is that each credit hour of class should correspond to about 4 hours of work per week. So we're in a 3 credit hour class here. That should be about 12 hours of work per week. So attending class, let's call that 3 hours, even though it's about 2 hours and 20 minutes. We'll say that the extra 40 minutes of that is glancing at the timestamp indices for the 2 classes you're not assigned to, and if there's a topic there that you feel like you'd benefit from, going and watching just that topic, okay? So that's 3 hours, okay. Content videos. In general, each week, the content videos themselves, without the quiz questions involved, adds up to around half an hour, okay? The quiz questions make it longer, and if you do it maybe 2 times going through it, which I would encourage doing not too many more times than that, just because the benefit to you from doing it 8 times to try to get the quiz up is just not worth the time. And let's suppose you're pausing it regularly to take notes and to really think about the questions that are being asked. So let's call that 2 hours to do all of those, instead of the half hour that are the actual video time. Reading the textbook, same thing. You can read all the assigned textbook readings in an hour. Let's call it 2, so assuming that you're spending that amount of time going through and taking copious notes, working some example problems, those sorts of things. The homeworks. The homeworks have hard data from across the nation about the time it takes different students to do it, and they give you a range of those. And if you take the minimum side of the range, you're looking at around 2 hours often. If you look at the upper end of the range, it may be like 4.5, but those are for people typically who have come into this class with some deficiencies in their, say, KM 111 comprehension, and this idea of 4 hours of work per week per credit hour is based on somebody who is up to date on their prereq information that they need. So I'm going to estimate 3 hours for the homework, okay? If you add all that up, there are still about 3 hours left per week. And so where does that go? Well, that gives us an opportunity to do the small group activities, gives you an opportunity to do the exams, gives you an opportunity to spend some time reviewing, those sorts of things. And you notice I don't give you a small group activity on the same week that you have an exam, right? If you are spending more time than those things than I just listed there on any of those topics, then that suggests you may be working too hard and not efficiently enough. The biggest way you can work more efficiently is to use me as a resource. If I'm your guide on the side, you have to call me in off the side when you're confused. I have my office hours every day of the week for a reason, and I paid careful attention to the surveys you guys sent me about when you would be able to attend office hours to ensure that everybody in the class had at least 1 or 2 per week that would meet their schedule, so they'd be able to come to at least one of them should they have questions. And I cannot tell you how many of my office hours I have when no one shows up. It's drop-in time that's one-on-one with me. I can clear up in 5 to 15 minutes something that you're beating your head against for 2 hours. That's what I'm here for. Use me. Okay. There's way too much going on to keep track of. I am very sympathetic to that because we do have a lot of components to this class. In the context of this video, I went through each of the components and saying, this is why I think this one is really important. This is why I think this one is really important, and so on. And what I came down to at the end was I didn't see anything that I could reasonably drop without sacrificing something major in terms of the learning process, except possibly Piazza. And I feel as though students are beginning to see value in Piazza, so I don't particularly want to drop that one. So watch the video, and then if you have some suggestions for something I should drop without sacrificing what I'm trying to accomplish with these things, I am absolutely willing to listen to that. Absolutely. My goal here is not to give you busy work. My goal is to give you specifically well-crafted tools to help you learn what you need to be learning. Okay, and then what are we going to do moving forward? So there are a bunch of things we're going to talk about in that. I have several of them in the video. I really want you to watch that. The third video, which I just got up yesterday afternoon, is a video that goes through the grade projection spreadsheet, which you now have access to, and goes through the new grading scale in some detail. That one, unlike the first two, is only about 10 minutes, so it's not going to take you too long. I do want to spend a little bit of time here talking about both the spreadsheet and the new grading scale and why it's set up the way it is, just to try to do a reset on trying to understand what we're doing. So let's talk about the grading system. So the points for the course grade is not changing from what's in the syllabus. But let's look at this. I already mentioned that participation, homework, and content videos, essentially the entire class is already on track to get 100% of those everywhere. Now, if I look at that conceptually, I'm going to trust that you guys, when you're doing Newton questions, that you are actually working towards 100% mastery within Newton in order to, and are legitimately answering the questions rather than just Googling the answers. I'm going to trust that. Now, in terms of an overall class grade, what does that say to me about your level of understanding? Well, we've already talked about the deficiencies of just basing everything off of Newton, but it doesn't mean nothing. It's a baseline upon which a real understanding can be built. So I look at that and say that by itself should probably account for a C-. That should be a pass. So if you get zeros on everything else, the new grading scale, but you get those 300 points at the top, you get a C- in the class. All right? Zeros on everything else, you get a C- in the class. So that means that the other parts, the activities, the midterm exams, and the final exams, think of those as points you are accumulating to bring your grade up from that C- to a higher grade, where what you are doing is demonstrating an understanding at an extent beyond what Newton is actually testing you on. That's the idea. So what that means, doing it this way, is that exams are designed to test that understanding rather than can you do the calculation, okay? Can you make connections between ideas? I don't see the point on an exam in asking a question where I fully expect everyone to get the answer correct, because that tells me nothing useful. I put that question on and hey, look, everybody got it right. But that's what you have to do if you're going to have a grading scale where D's start at 60%. 50% of the points have to be things that everybody should get right. Right? The useful questions are the ones where some people get it right and some people don't, and that then gives me information about what people know and what people don't. What that means is that the best average for an exam is 50%. And you want the spread wide across all the way from 0 to 100 so that I'm getting as much information as possible about what people do know and what people don't know. So don't look at the number and say that's an F, because it's not. Now, in order for that to work, I have to adjust the grading scale down in terms of points, which is what I've done. And I go through that in detail in the video I mentioned here, where I go through the grade projection spreadsheet and then the grading scale. If you end up with the averages in small group activities and the averages on the exams, you will be in the B range. And I have it set up so that if I correctly am able to target the exams how I want to target them, and I will absolutely admit, exam number 1, I went a little too far. It was a bit harder than I really wanted it to be. Because I want the averages to be closer to the 50 rather than the 30. We have redemption points, which I'm going to talk about in a minute. So I'm going to be scaling it back some. But I have it set up so that if I can get the exams where I want them to be, then assuming that everyone does the 300 points that everybody can do, and then gets the distribution I'm looking for on the exams, we're looking at about an equal distribution between C's, B's, and A's, which I think is relatively generous, because there are a lot of people, a lot of instructors who say, the average of a class ought to be a C. But I'm saying that, grasping the material to the point of Newton level knowledge, which everybody is doing, that should be at least a C. So I'm going higher than that. Now, this is hard for some people to wrap their brains around when they're used to every assignment being graded on the same scale of everything. So the homework, the numerical grade on a homework is predictive of what your numerical grade on an exam is going to be. I understand that's hard to do. That is why I have a grade projection spreadsheet that is now available on Blackboard for you to download and use. I know this is illegible, but I just want to, the video is only 10 minutes. We'll take you through how to work it. The idea is that you input what your actual grades in various categories are. Within each of those categories, it then says, all right, homeworks. I've got an 80, I've got an 80, I've got 100, I've got 100. Let's average those so far, and then say, all the ones that you haven't done yet, what if you perform at the same level? We'll put that in at the same level. It then goes through and figures out dropping grades, because a couple of grades from each of the categories gets dropped in many cases, and then averages it together, and then carries it over to the projection over on the side of how many total points you're going to get. It also takes into account redemption points. So as a reminder of that, the final exam is going to be divided into four sections, each section corresponding to the midterm exam, to one of the 4 midterm exams. If your percentage score on that section of the final exam is higher than your score, which is out of 100, so it's a percent, on the midterm, your midterm score gets bumped up because you've now demonstrated a higher level of understanding. Okay. It's not going to go the other way. It's not going to bring it down, but it's a way to bring it back up. And the spreadsheet takes that into account and projects forward what your grade is going to be numerically, what the letter grade will be based on the new scale that we have, and the number of points necessary to get to the next grade cutoff. And so you're entering, there are 2 yellow columns and a green column in each of these various categories. So we have homeworks, content videos, participation, group activities, exams, and extra credit. There are 2 columns in yellow. The first one is you put in your actual grades. The green is what the projections are. The middle yellow one, where you can also put in numbers, is where it lets you play what-if scenarios. You can say, all right, I'm going to redouble my efforts on the small group activities, and I'm going to try to get up to a 90% on those. Type in 90s for those and see how that affects your grade. Same thing on the exams. Okay? Yes? Mm-hmm. So for people on Zoom, the question was about feeling as though the 5 o'clock deadline is inconvenient and rushing of people because of working, because of caretaking, various things like this, and having it later than that in the evenings would relieve a great deal of that stress. Am I accurately representing how you expressed that? Okay, thank you. So, as I've mentioned, the reason that I went with the 5 o'clock is that is the recommendation by the central organization at BSU that instructs professors on how to be good instructors, that 5 o'clock kinds of deadlines better promote student self-care. The general advice that they give associated with people who work during that period is for us to make, as instructors, to make sure that the assignments are available sufficiently in advance that people could have it done the day prior for it. So I'm basically going with what seem to be the university established best practices on that. So if there is ever a case where where an emergency comes up and that's the kind of that kind of problem shows up unexpectedly, or if I give you an assignment without you having it with enough prior time to be able to schedule it in on a prior day, then I am absolutely open to finding ways to extend. To give extensions individually on that sort of thing. But in cases where you have the assignments sufficiently early that you can plan to do it on a prior day, then I have to say my inclination is to continue to go with the guidelines from the university. You're welcome. Okay, so that's the grade projection spreadsheet. And so what I really want you to be thinking about is minimum level of performance is the Newton style questions. You do that kind of work and you are guaranteed a C-. And the exams and the small group activities are accumulating points towards a higher grade by demonstrating an understanding level that is beyond what Newton is asking of you. Okay. All right. That clock is way off. Okay. Right. Good. Okay. So one suggestion that came up was that came up on on Newton was giving you guys an equation sheet before the exams. I love that idea. I know that you have access to all of the information, can make your own equation sheet, but having me provide you with one can help organize that information in a good way, and so I'm planning to do that. I have already gone back to the exam 1 material and created that equation sheet and put it on Blackboard so that you can see the kind of format it's going to be in, and when looking at the final exam that's going to be coming up, you'll have that ahead of time. So I wanted you to be able to have access to that. There have also been requests for more kinds of practice problems that are going to be more similar to the exam kinds of questions. I'm going to explain why it didn't happen this time, and then explain what I'm going to try to do to fix that going forward. So the reason it didn't happen this time was that I didn't have the exam written until about 3 or 4 days before the exam was being released. And because it's really hard to write an exam that is at the right level of probing for your understanding. And when I'm trying to probe for your understanding, it's rather than can you do exactly the formula that you've seen before, that's a careful balancing act, so it's hard to write those. So I very simply didn't have the exam, and so I couldn't say this is what it's going to look like, because I didn't know what it was going to look like at that point. What am I going to do to help fix that problem? So what I'm going to do is start working on the exam questions as we are covering the topics as we go through. Okay, so we cover a topic. I'm going to set aside a little bit of time at that point, figure out what the exam question related to it is going to be, and that's going to then give me the opportunity to be able, as we go along, to give you some examples that are going to be more similar to what's going to be on the exam. Okay. It's not going to be exact, because the whole idea is seeing if you can take the ideas and make connections in a context where you're having to apply it in a different way. I do not almost ever give, do you recall this fact kinds of questions, because in this age, you have Google. You can always look up a fact. I can always look up a fact. I don't believe that memorization tests whether you know something. And so I always am trying to construct questions that you can answer correctly if you can see connections of information. But you have to be able to see connections of information in order to answer them correctly. So that's what I'm going for. So I had mentioned at the beginning of this that there are some pieces of background information, like identifying whether a compound is ionic or not, like dimensional analysis, that I have been surprised at the lack of ability to use that information in context for this semester's material. And so I had thought that what I could do yesterday and today would be to go through one or two of those ideas to try to bolster that understanding. I tried to do that yesterday with dimensional analysis, and I was told pretty roundly at that point, no, we get dimensional analysis. And okay, I get that. But so I don't want to necessarily lecture at you about something that you actually do feel really confident about. But that is kind of what I was planning to do. If people would like me to, I am happy to do that. If people would find something else useful for me to do at this time, I'm happy to do that as well. I'm also happy to go over specific exam questions. One thing I didn't talk about here that I absolutely need to, before I get to that. regrade requests, right. So, one of the things that I had said that I wanted to do on the exam was to be able to give you intermediate steps where you can do part of a calculation so that you can get partial credit even if you don't get the final answer down at the bottom. Okay. And I said that I really wanted to find a way to, so that if you got a question wrong up here but did the calculations from that correctly, that this wrong answer would be counted correct because you got from here to here correctly. I spent I'm not even going to tell you how many hours trying to find a way to do that, either within Newton or within Blackboard, and I could not. I could not find a way to make that happen. And that's not how I want to grade. I want the grades to, if you actually demonstrate you understand something, I want you to get credit for it. So the way I'm handling it on this exam is that I have put up a form on Blackboard for regrade requests. I've gone through the exam and I've identified which questions you depend upon answers from prior questions where it's reasonable to say, if you got this question wrong but did the calculation to here correctly, then you ought to get the points. And so I have a form on Blackboard that lists those out and says, I want a regrade on these questions, okay? Now, the problem with this is that if I just did that, then I could see the entire class, every single person in the class, sending me in that form with every single one of the boxes checked and saying, regrade them all. I might get a point, right? It's kind of in a fishing expedition. And I'm behind on enough other aspects of grading of this class that that's not good for you and it's not good for me. So what I am doing is instituting a policy with this where where it is your responsibility to double check before you send it to me that you have done, that you actually did do the calculation from question X to question Y correctly. And I have the content, the video where I do the exam walkthrough, where I talk through how each question is done, so you have in that video the information you need in order to see what is the procedure to go from question X to question Y, and you can plug it into your calculator and figure it out if you did it right. And so the way I'm implementing this is you can send me whatever you want, and I'm going to go through and I'm going to start looking at regrades on those. But I have a spreadsheet where I have all of the calculations in it for what should happen. If you put in a wrong answer here, I type in the wrong answer and I see what answer you would have gotten. I'm going to be using that as I go through and do the grading. The first one I get to on your submission where no, your answer as submitted on the exam was not what you would get if you did that calculation correctly, I'm done with your regrade. You don't get any points, okay? So I want to give you points back, so don't let that scare you. I'm not going to dock any extra points or anything like this. But if you want points back, if you think you did a step correctly, make sure of it and then submit it to me, and you'll get those points back. But do not go on a fishing expedition, because you won't get anything. Make sense? And you can post it on Piazza if you want, and, or bring it up to me in office hours or something and say, hey, I think I might have done this right, but I can't quite tell. Can you help me through it? Yeah, I can. That's fine. That's part of the learning process. That's calling me in as the guide on the side to help you. That's what I'm here for. So let's do that. Okay? Yes?
So I have a quick question. If enough people send in like regrade requests and they get a substantial amount of points back, is that going to change the grading curve?
No. So the way the grading curve is set, I told you that what I want for the exam grades is to have a mean at 50 with a distribution of about standard deviation of about 34, so that I have a big spread of the data. With that assumption, that suggests that on the final exam, redemption points will kick in for almost everybody on exam number 1, and everybody's exam number 1 is going to get up to the 50% kind of range. So the grading scale that we have right now is based on 50 as the average on the exams with that distribution. Now, I am going to keep my pulse on that. I'm going to keep watching this. When exam 2 comes out, if I missed my mark and it's not up at the 50 that I want, then I can continue to revise the grading scale to compensate for that, and I absolutely will. I will never adjust it the other direction. I will never say, oh, you guys did too well on that, I'm going to make the grading scale harder. I will never do that. Okay, make sense? Okay. Let me see if there are any questions in the chat. So last week's homework is due Friday, and anything that would be due this week is due next week. So next week is still up in the air because I have not had a chance to reshuffle things based on taking this sort of week pause as we catch our breath. So yes, there's a bunch that is currently listed as due next Friday, but it is not going to stay that way. That's going to get distributed so that no week going forward is going to have a major increase in the amount of work that's necessary. Okay, I thank Harrison for the thoughts on due dates and times, and I understand it, and I'm still absolutely considering other options, but I may need to consult with the Center for Teaching and Learning and see if they have thoughts on it and whether this is something I should respond to or something that I should stick with the policy on. Okay. Okay, so we are currently at 12:53 based on a correct clock. So the question at this point is, with the 18 minutes that we have left, is there anything you would like me to do? I would be very, very happy to go through an introduction to dimensional analysis if you would like. I would be, talk about how that specifically applied to some of the exam questions that were relatively easy. If you approach it from a dimensional analysis perspective, what do people think about that? I saw one person nod. Is this something that people would like? Okay, I'm seeing a couple more nods. Okay, so let me switch this back to the screen here. So I'm going to very briefly give you the theory of dimensional analysis, and then I'm going to look at some applications of it. The idea is that it's a four-step process. Start with what you know. Multiply by 1. Repeat step 2 as needed. Arrive at your answer. Now, when I write this out in this way, steps 2 and 3 sound utterly useless, and step 4 sounds like magic. But what I'm going to show you is how careful, clever use of step 2 can turn this into the most powerful problem-solving tool that exists in chemistry. So let's start by looking at an example that you are already familiar with, where multiplying by 1 helps you. 1/2 plus 1/4. We need a common denominator. So we multiply the 1/2 by 1 in the form of 2/2. Multiplying anything by 1 does not change its value, right? But there are different ways to express 1 which allows you to multiply by things to get things into a form that make it really useful. So let's extend that idea a little bit further. I hope you all agree that it's a true statement that 12 inches equals 1 foot. Now, let's divide both sides of this by 12 inches. So that means that 1 foot over 12 inches equals 1. And we can now multiply things by 1 foot over 12 inches without changing what we have. So if you have something that is 60 inches long, you start with what you know, and then you multiply it by 1 in the form of 1 foot over 12 inches. We see that the units cancel, and you end up with 5 feet. That is the basic idea of dimensional analysis. And I know many of you were probably taught this using the railroad tie kind of thing, like this. Is that familiar to some of you? I discourage this because we already have a notation that reminds you of what you're doing. The notation of multiplying by fractions, okay? And so this is, in my opinion, helping you forget what it is you're actually doing when you do dimensional analysis. So how did this concept come up in the exam? So do you remember the question that, so in one question you identified the osmotic pressure of seawater. If I remember correctly, the answer to that was something like 27 atmospheres, 27.1 atmospheres, something like that. Right? And then you were asked what height of seawater would be necessary in one of these U-tubes in order to counteract the osmotic pressure that you have. And you were given the information that 1 meter of seawater gives you 0.123 atmospheres of pressure. So if these two things are equal, then that means this is a conversion factor. So 0.123 atmospheres, 1 meter, atmospheres cancel, 27.1 divided by 0.123, and you get your answer, if I remember correctly, of 223 meters of seawater. So the question was in fact that simple. And by being comfortable enough, fluent enough with dimensional analysis, you don't have to say, oh, I've never been given a formula for determining the amount of seawater I need. 99% of chemistry is not formulas. 99% of chemistry is relationships between information that you convert from one to another. So that's one reason why initially I was not all that excited about giving you guys a formula sheet, because that emphasizes the idea of these formulas. And yeah, there are some formulas you need to know. You need to know the osmotic pressure formula. You need to know Raoult's law for vapor pressure depression, things like this. So there are certainly formulas that are involved. But almost always, those formulas are then followed by unit conversions of some sort, or not even necessarily unit conversions, but conversions from one stoichiometric quantity to another stoichiometric quantity. Or in this case, pressure to amount of water, which seems like a strange thing to convert between. Is that really a conversion factor? Well, it is, because it converts the information. Okay. The very first question on the exam, the first 11 questions, were conversions from parts per thousand by mass to molarity? Well, it's a very reasonable thing for people to say, you never gave us a formula to convert between those two things, until you think about, well, all it is a dimensional analysis problem. Write down what parts per thousand by mass means, write down what molarity means, which is what you're trying to get to. Now, what do I need to do to convert the numerator into what I need the numerator to be, and what do I need to do to convert the denominator into what I need the denominator to be? That's not a formula. That's a set of relationships. Because if you learn the formula for one specific conversion, then you now know how to do that one specific conversion. But if you learn the ideas of thinking about conversions, then you can do any conversion. Does that make some sense? So I have an extended example here, which I'm probably not going to go through, but I may post it for people to look at. You and your 3 friends want to take a road trip, round trip, to Mexico City and want to split the gas costs evenly. Now we've got distances, in some cases in miles, in some cases in kilometers. We have the cost of gas here in Boise, we've got the cost of gas in Mexico City, and in one case it's dollars per gallon, in another case it's pesos per liter. Gas mileage of your car in miles per gallon, and then a bunch of conversion factors. Now, this is not chemistry, right? But this is completely and utterly solvable by dimensional analysis. And going through the process of figuring this out and writing it as a single string of multiplying by 1, actually 2 strings, because you have to do once for the US and once for the Mexico part, and then you add them together. So you'll do 2 separate dimensional analyses here. But going through the process of figuring out, how do I do the unit conversion? How do I make sure that the units that I want to cancel as you go through it is great, wonderful practice for solving chemistry problems. Make some sense? Okay. We have about 8 or 9 more minutes. Is there anything else anybody would like to talk about? So from the chat, no content videos this week. That's correct, no content videos this week. We are picking up again fresh next week. I've got a couple of them scripted and ready to be recorded, and I'll finish the rest of them up in the next day or so, so you'll have time to work on those. There was some concern, which a very valid concern, about on Piazza, somehow a setting got switched so that sending me private messages seems to not be working unless you have marked a bunch of things as red, and people are saying that they have marked things as red and they still can't get to me. I'm going to be, first thing this afternoon, I am going to be trying to debug that and solve that problem. And I'll post whatever the solution to that problem is. I anticipate being able to have that solved probably by, I'm guessing about 3 o'clock. So, because that's what I'm going to really focus on first thing, because I do want everybody to be able to get in touch with me. Nobody has anything else? All right, thank you very much. I will be spending tomorrow and Thursday both going over Piazza Muddiest Points on the kinetics stuff for the homework this Friday, which was the one that was originally due last Friday. And I will have the materials for next week up as soon as I can. Thank you all. Oh, and please remember, I am specifically asking you to watch those 3 videos. I know 2 of them are long, but there's a reason for them to be there, and I think it is useful for you to go through them. Thank you. Yes, sir. Yeah.
I was just genuinely curious, although I know that your schedule's